Tonight, we are going to talk about why the universe is disappearing. Not because stars are being destroyed, not because galaxies are falling into a giant void, and not because the universe is ending tomorrow, but because space itself is expanding. Everywhere, on itself, is expanding. Everywhere, on the largest scales, galaxies are moving away from each other. The farther a galaxy is, the faster it appears to recede from us. And beyond a certain distance, the expansion of space becomes so powerful that light from those galaxies may never reach us again. This means the universe we can observe today is not permanent. The galaxies we see in deep space are not guaranteed to remain visible forever. Over immense stretches of time, more and more of them will fade beyond our cosmic horizon until the night sky of the far future becomes darker, emptier, and strangely silent. One day, future civilizations may look into space and see almost nothing beyond their own local group of stars. They may never know how vast the universe once appeared. So tonight, the question is simple. Why is the universe disappearing? Before we begin tonight's journey, subscribe to the channel if you want more calm space documentaries like this. Leave a like if you enjoy slow journeys through the mysteries of the universe, and write in the comments where you are watching from and what time it is where you are right now. It is strange to think that we are looking at the universe during a rare window of time when distant galaxies are still visible enough to tell us the story of where everything came from. Tonight, you are watching the Just About Space channel, talking about the universe is disappearing for a reason, and it's terrifying. The strange part is that this disappearance has already begun. Not in a way we can see by looking out the window tonight. The stars over our heads are not suddenly vanishing one by one. The moon is still there. The planets still move through the sky. The Milky Way still arches across dark places on Earth, where city lights do not hide it. On human timescales, the night sky feels permanent. But on cosmic timescales, the view is changing. The universe we see is not a fixed picture. It is more like a moving photograph, a view from one moment in a much longer story. We live during a certain age of the universe, and that age gives us a certain kind of sky. If observers exist far in the future, their sky will be different too. That is the first unsettling idea. The visible universe is temporary. Every distant galaxy in a deep field image is not just a place. It is also a time. When we look far away, we look back. Light travels at a finite speed, so a galaxy billions of light years away is shown to us as it was billions of years ago. The sky is not only a map of places, it is a layered record of the past. But that record is not permanent. The most distant galaxies are not simply sitting there, waiting forever to be seen. On the largest scales, the universe is expanding. Space itself is stretching between distant galaxies. Over time, many of those galaxies become more and more separated from us. Their light is stretched. Their signals grow weaker. And because the expansion of the universe appears to be accelerating, there are regions that will eventually become unreachable in a deeper sense. This is what makes the idea so terrifying. The universe is not disappearing like a candle being blown out. It is disappearing from access. It is moving beyond what can ever be seen, reached, or known from here. That is why the phrase, "the universe is disappearing," has to be understood carefully. Galaxies are not all being destroyed at once. Stars are not all burning out tonight. We are not watching a sudden collapse. The disappearance is slower, colder, and stranger. It is the slow loss of visibility, the slow removal of distant places from the part of reality that can ever send light to us. And the most unsettling part is that this is not science fiction. It is built into the future implied by cosmic expansion. In the far future, the sky may tell a much smaller story. Distant galaxies will be redshifted so far that their light becomes extremely stretched and faint. Many will slip beyond the cosmic horizon, meaning light they emit later will never reach us. The universe beyond the local gravitational neighborhood will become less visible, less measurable, and eventually almost impossible to detect. Future observers may look out and see a far emptier sky. They may not see a universe filled with galaxies. They may see a dark island, a merged future galaxy surrounded by silence. That idea changes the emotional meaning of astronomy. When we look into deep space now, we are not just satisfying curiosity. We are seeing something that future observers may not be able to see in the same way. Our age of the universe gives us access to evidence that could one day fade beyond reach. The sky we study is not only vast, it is a temporary opportunity. This is why the night sky is more fragile than it seems. Not fragile in the human sense, where something can be broken by touch. Fragile in the cosmic sense, because what it reveals depends on time. The stars nearby may remain. Our galaxy may remain. Nearby galaxies bound by gravity may remain. But the wider cosmic web, the huge population of distant galaxies that tells us we live in a vast expanding universe, is slowly becoming less accessible. The universe is not only expanding, it is hiding its own history. That horizon is not a physical wall. There is no glass shell around us, no edge where space stops, and no final border with darkness on the other side. It is a limit, created by time, light, and expansion. The universe has an age. Light has a speed. Space has been expanding while light travels. Those three facts combine to create a boundary around what can be observed. That boundary is one of the most important ideas in this story. Because if there is a horizon, then there can also be loss. A galaxy can be visible in one era and unreachable in another. Light it emitted long ago may still arrive today, allowing us to see its ancient image. But light it emits in the far future may never arrive, because the expansion of space carries that galaxy beyond the range from which new signals can reach us. In a very real sense, the galaxy becomes part of a past we can see, but not a future we can contact. This is deeply strange. We can see some galaxies as they were, but we may never interact with what they become. The universe allows us to receive old light from places that are already slipping away from any future connection. The image is real, but the relationship is fading. The more the universe expands, the more the distant cosmos becomes like a museum of unreachable past events. This is why the first chapter of this journey has to begin with the idea of impermanence. Before we explain dark energy, before we talk about the accelerating universe, before we imagine future civilizations looking into an emptier sky, we have to understand that our current view is not eternal. We are seeing the universe during one window in its lifetime. And that window is precious. Right now, the cosmos is old enough for stars, planets, chemistry, and observers like us to exist. It is old enough for galaxies to have formed and evolved. But it is not so old that the distant universe has completely faded from view. We live between two extremes. We are not at the fiery beginning, and we are not in the final darkness. We are in the middle age of cosmic visibility, when enough time has passed for intelligence to ask questions, but not so much time that the evidence has disappeared. That timing matters. If life had emerged much later, the universe might look lonelier. The sky might still have stars, but the grand evidence of cosmic expansion could be harder to find. The distant galaxies that now reveal the scale and history of the universe might be gone beyond the horizon. The cosmic microwave background, the ancient afterglow of the early universe, would be stretched and weakened beyond easy detection. Future astronomers might have fewer clues to reconstruct the true history of reality. They might believe their galaxy is almost alone. They might not know that the sky once contained billions of visible galaxies beyond their local region. They might live inside the same universe, but with a smaller window into it. This is one of the loneliest ideas in cosmology. The truth can become harder to discover over time. Not because the truth changes, but because the evidence moves away. That is very different from the way we usually think about science. We often imagine that the future always knows more than the past. Better instruments, better theories, better technology. In many ways, that is true. But cosmology has a strange exception. If the universe continues expanding and accelerating, the far future may lose access to evidence that is available now. Future scientists may be smarter, more advanced, and more patient, but still have less cosmic information to work with. The universe can become harder to understand as it ages. That is the terrifying part. Not terror like a monster in the dark, but like a library slowly moving beyond reach, shelf by shelf, until only a few books remain in the room. This does not mean we should imagine the sky suddenly going black. The timescales are enormous, far beyond human lifetimes, civilizations, and even the lifespan of many stars. The disappearance is not an event anyone alive today will watch in a single night. It is a long, cosmic trend. The same sky that feels stable to us is part of a process that stretches across billions and trillions of years. But slow does not mean unimportant. Some of the most important things in the universe happen slowly. Stars form slowly. Galaxies evolve slowly. Orbits shift slowly. The future darkness of the universe is not less real because it takes an unimaginable amount of time. In fact, the timescale makes it more unsettling because it shows how small human time is compared with cosmic time. The disappearance of the distant universe belongs to these enormous scales. It is not a human disaster. It is a cosmic destiny. It is the slow transformation of the visible universe from rich and crowded to isolated and dim. That is why the idea works so well for a calm documentary. It is not loud. It does not need explosions. It does not need fake panic. The truth is already heavy enough. The universe is changing in a way that will eventually hide most of itself from anyone still trying to look. And once we understand that, the question becomes unavoidable. Why would the universe become less visible over time? Why do galaxies move away from us? Why does distance grow between the larger structures? Why can some places pass beyond any future contact? The answer begins with expansion. But expansion is often misunderstood. Many people imagine the Big Bang as an explosion that happened somewhere, sending galaxies flying outward through empty space. That picture is simple, but it is not the real idea. The universe is not expanding from one central point into a larger empty room. Instead, space itself is expanding. The distances between faraway galaxies grow because the fabric of space between them stretches. This is where the next part of the journey begins. Because if we want to understand why the universe is disappearing from view, we first have to understand what it means for space itself to expand. The galaxies are not simply running away through space. Space is growing between them. That is the idea that changes everything. It changes the story from motion to geometry. If galaxies were only objects flying through a fixed emptiness, then the future would be easier to imagine. But if the emptiness itself changes, then the rules become stranger. Distance is no longer only something objects cross. Distance is something the universe can create. When people first hear that the universe is expanding, it is easy to imagine an explosion, a bright beginning somewhere in the distance, with galaxies flying outward like fragments from a blast. It feels natural because explosions are familiar. Something starts in one place, energy pushes material outward, and the pieces move through the space around them. But the universe is stranger than that. The expansion of the universe is not galaxies racing away from a central point through a pre-existing emptiness. There is no known center that everything is fleeing from. On the largest scales, it is space itself that changes. The distances between faraway galaxies grow because the fabric of space between them stretches. In the universe as a whole, space is not just a silent stage where galaxies perform. Space is part of the story. It can expand and carry distant galaxies farther apart, without those galaxies needing engines, fuel, or a direction of travel in the normal sense. That is one reason the Big Bang is so often misunderstood. The Big Bang was not an explosion at one location inside space. It was an expansion of space itself from a hotter, denser state. When we look backward in time, galaxies were closer together, and the universe was denser. As time passed, space expanded, matter spread out, galaxies formed, and the universe became the vast structure we observe today. But expansion does not mean everything is expanding in the same way. Gravity, electromagnetism, and other local forces hold smaller systems together. Atoms, planets, stars, galaxies, and even groups of galaxies can remain bound if the local forces are strong enough. Cosmic expansion dominates on the largest scales, between distant galaxy groups and clusters, where objects are not gravitationally tied together strongly enough to resist the growth of space between them. The disappearance of the universe is therefore not happening inside our room, our planet, or even our galaxy. It is happening across the largest distances. It is a cosmic scale effect, and on those scales, it is relentless. This is why the night sky can look calm, while the largest structure of reality is changing. The familiar world remains stable because local forces hold it together. But far beyond the Milky Way, across the deep spaces between galaxy groups, the stretching continues. The process is too large and slow to feel, but it shapes the fate of the observable universe. The farther away a galaxy is, the faster it appears to recede from us. Distance and recession are linked. A galaxy twice as far away, on average, recedes faster. This is not because we are at the center of an explosion. It is because every large stretch of space adds its own expansion. It is not necessarily that a galaxy is flying through space faster than nearby galaxies. It is that the space between us and that galaxy is stretching, and over very large distances, the total stretching becomes enormous. This is where the terrifying future begins to appear. If distant galaxies can recede because space itself expands, then there can be galaxies so far away that the expansion between us and them prevents new light from ever reaching us. Their old light may still be arriving today, showing us their ancient past. But light they emit now, or light they emit in the far future, may never overcome the expansion enough to reach our part of the universe. A place can become so far, and space can expand so much, that no message sent from there can ever arrive here. No telescope can collect light that never reaches it. No future civilization can observe a signal that expansion has carried forever beyond its horizon. This is the deeper meaning of the universe disappearing. Not that the galaxies all vanish at once, not that matter is erased, but that the connection between regions weakens and eventually ends. The expansion of space turns distance into isolation. That isolation is not emotional, but physical. It means there are regions that can share a past with us, because old light from them is still arriving, but may not share a future with us, because new light will never make the journey. The relationship becomes one way. We can observe what they once were, while losing access to what they become. To understand this, think of light traveling through a universe that is changing while the light moves. A photon leaves a distant galaxy and begins its journey. But while it travels, the space it crosses continues to expand. Its wavelength stretches, making the light redder, and its energy drops. This stretching of light is called redshift. Distant galaxies appear redshifted because the wavelengths of their light have been stretched by the expansion of space. The more the universe expands during the light's journey, the more the light is stretched. This is one of the major clues that revealed the expanding universe. But if expansion stretches light, then the far future becomes darker. As galaxies move farther away, their light becomes more stretched, more redshifted, and harder to detect. A galaxy that once appeared visible in deep space can fade, redden, and slip away from practical detection long before it is gone, in any physical sense. The universe can hide something without destroying it. That is one of the strangest ideas in this story. A galaxy can still exist, still contain stars and planets, and yet become effectively unreachable from here. The darkness grows not because the galaxy stopped being real, but because expansion has changed what can be shared between us and it. That is why expansion is not just a background fact. It shapes what reality can reveal. The universe may be full of galaxies, but if their light can no longer reach a future observer, then for that observer, those galaxies are absent from the observable universe. They may exist beyond the horizon, but existence beyond observation becomes almost unreachable knowledge. A horizon is not the same as an edge. This is important. When people hear observable universe, they often imagine a bubble with us at the center and a physical boundary at the edge. But the boundary is not a wall in space. It is the limit of what light has had time to show us. Another observer far away would have their own observable universe, centered on their location. The horizon is about information. It is about what can reach whom. Cosmic expansion changes those information boundaries over time. It determines which signals can arrive, which signals will be delayed, and which signals will never arrive at all. When expansion accelerates, this becomes even more dramatic. Some galaxies are not merely far away, they are becoming forever separated from our future. This is why space itself is expanding is not just a technical explanation. It is the mechanism behind the disappearance. If galaxies were only moving through a fixed space, the story would be different. But if the space between galaxies grows, then distance itself becomes dynamic. The universe is not a stage with objects moving across it. The stage is stretching, and that changes the fate of every distant light beam. That is what makes the universe feel alive in a strange, impersonal way. Not alive like an organism, but like a geometry that evolves. The background is not fixed. The distances are not eternal. The horizon is not static. The part of the cosmos that can speak to us changes with time. That is why the universe is so hard to visualize. We are trying to understand the whole system while being part of it. Every measurement comes from inside. Every telescope looks from one location within the expansion. The universe was hotter and denser in the past. It expanded, cooled, formed structures, built galaxies, lit stars, and made planets. And now, billions of years later, observers inside one galaxy can measure the expansion that shaped everything. But the same discovery that gave us cosmic history also gave us cosmic loss. If space expands, distant objects recede. If the expansion accelerates, many become unreachable. If enough time passes, the visible universe becomes poorer. The knowledge that reveals the universe also reveals that the universe will hide itself. This is why this part of the journey matters so much. The universe disappearing is not magic. It is the consequence of a real physical idea. The growth of space on the larger scales. Before dark energy, cosmic horizons, or the far future, we need to understand that galaxies are not simply moving away from one central explosion. The distances themselves are growing, and if distances can grow, then distance can become destiny. A galaxy that is only far today can become unreachable tomorrow, in cosmic terms. A signal that could once arrive can later be trapped beyond the horizon. A sky filled with galaxies can become a sky that looks almost empty. This is the quiet terror of expansion. It does not attack. It does not explode. It simply continues. And because it continues everywhere on the largest scales, the effect builds quietly over time. The universe does not need to destroy a galaxy to remove it from our future. It only has to stretch the space between us long enough. Space grows, light stretches, galaxies recede, and the observable universe slowly loses parts of the story it once allowed observers to read. But to understand exactly how that loss happens, we have to move from the idea of expanding space to the idea of a horizon. Because the universe is not only expanding around us, it has limits around what we can ever see. This is where the idea of the cosmic horizon begins. It is not the place where the universe ends. It is the limit of what can reach us. When we talk about the observable universe, we are talking about the part of the universe whose light has had time to arrive here. Light travels at a limited speed, and space has been expanding while that light travels. So there is a boundary around what we can observe. Not because reality stops there, but because information from beyond that region has not reached us. This is one of the most important ideas in cosmology. The observable universe is not the whole universe. It is only our visible portion of it. There may be much more beyond what we can see. Galaxies, clusters, stars, planets, and regions of space outside our current view. But if their light has not reached us, then they are not part of our observable universe. They may be part of reality, but they are not part of our sky. That distinction changes everything. When people imagine the universe, they often imagine one huge container with all galaxies inside it, and they imagine our telescopes slowly seeing farther, until one day we reach the edge. But the observable universe is not an edge in that simple way. It is a bubble of information around us. This is why the phrase, edge of the universe, can be misleading. There is an edge to what we can observe, but that is not necessarily an edge to everything that exists. The cosmic horizon is an information boundary. That makes it very different from the edges we know in ordinary life. An ordinary edge is something you can point to. The edge of a table, the edge of a cliff, the edge of a shadow. The cosmic horizon is not like that. It is not a physical surface waiting somewhere in space. It is a limit in the relationship between us and the light traveling toward us. This is why the horizon can exist even in a universe that may continue far beyond it. It is not telling us where reality stops. It is telling us where our evidence stops. And once we understand that, the disappearance of the universe becomes much more precise. Galaxies are not vanishing because they hit a physical wall. They are vanishing because the connection between their light and our future is being stretched away. That is terrifying because it means the universe is not only large, it is divided by what can ever be known. A galaxy can be visible in an ancient image because light it emitted long ago is arriving now. But that does not mean we can see what is happening there today, or that light it emits now will ever reach us in the future. This creates a strange relationship with distant space. We are not looking at the present universe. We are looking at layers of old light. The deeper the layer, the older the message. A nearby galaxy shows us a more recent version of itself. A very distant galaxy may show us a young version from billions of years ago. In one direction, the sky can show us a mature galaxy. In another, it can show us a galaxy from when the universe itself was much younger. The night sky is not arranged by time in a simple way, but every direction carries time inside it. That means the universe is not only around us. In a sense, the past is around us too. When a deep telescope captures galaxies from the young universe, it is not photographing them as they are now. It is receiving light from an earlier era, light that has been traveling across expanding space for an immense time. Those galaxies may have changed, merged, or moved beyond future contact, but their ancient light is still arriving. This is why astronomy can feel so beautiful and so lonely at the same time. Beautiful, because the light made the journey. Lonely, because the thing that sent it may already be beyond any future conversation. A telescope can receive the ancient glow, but it cannot force the universe to keep the channel open forever. The universe allows us to see its past, but not always its present, and sometimes not its future. The cosmic horizon marks the limit of this conversation. Everything inside our horizon can, in principle, send light that reaches us, at least from some period of its history. Everything beyond it is outside direct observation. We may infer that it exists, but no telescope can simply point farther and collect light that has not arrived. This is where expansion becomes more than a motion of galaxies. It becomes a filter on reality. The universe may contain an enormous amount beyond our horizon, but observation depends on light, and light depends on the path space allows it to take. If space expands too much during the journey, the message never arrives. The event remains outside our possible knowledge. This is not the same as saying we know nothing about what lies beyond. Cosmology can use the part we see to make reasoned conclusions about the larger universe, but the direct evidence still comes from inside the horizon. As the universe ages, the horizon changes. Some old light continues to arrive from distant galaxies, but new light from many regions becomes unable to reach us. The objects become more redshifted, dimmer, and more disconnected from our future. The accessible part of the universe becomes dominated more and more by what is gravitationally bound nearby. Not completely for us in any human lifetime. Not like a curtain dropping at the end of a show. But over immense stretches of cosmic time, the view changes. The distant universe moves beyond reach, not because space has an edge, but because expanding space changes which signals can cross it. This is especially important when we think about distant galaxies. The galaxy whose light reaches us today may already be beyond the distance from which light emitted now can ever reach us. We can receive old light from a galaxy while losing any future connection to its present. The galaxy is visible and unreachable at the same time, visible in the past, unreachable in the future. That is the heart of the disappearing universe. It means the sky contains ghosts of connection, images from regions that can still show us what they once were, even as expansion removes them from what they can ever tell us next. We are surrounded by ancient signals from places whose future light may never arrive. The cosmic horizon also changes how we think about the word now. On Earth, now feels simple. In the universe, now becomes difficult to cross enormous distances. Because light takes time, we do not see distant objects as they are at this moment. We see them as they were when the light left. Every galaxy is a message. Every redshift is a clue. Every patch of ancient radiation is a remnant. Every horizon is a reminder that the story has limits. The observable universe is not a complete book. It is the part of the book whose pages have reached us, and over time, fewer future pages from distant places will arrive. This is the quiet horror behind the cosmic horizon. It is not an explosion, not destruction, not a sudden end. It is the fact that the universe can be full of things that are no longer part of our possible future. Galaxies can become locked behind the horizon, not by a wall, but by the continuous growth of space. Once a signal is beyond that future limit, waiting longer will not help. Time, which usually allows light to arrive from distant places, becomes part of the problem. More time means more expansion, and more expansion means some distances become harder for light to overcome. That is what makes our time special. We are not at the beginning, and we are not at the end. We live during an era when the cosmic horizon still lets us receive enough ancient light to understand a much larger story. We can still see distant galaxies, detect early universe radiation, measure expansion, and learn that our galaxy is only one among many. Our sky is rich with evidence, but that richness is not guaranteed forever. The cosmic horizon tells us that the universe is not only a place, it is an opportunity to receive information while information can still arrive, and to understand cosmic history before much of the evidence fades into unreachable distance. That opportunity is easy to take for granted. We live under a sky that still contains clues from many chapters of cosmic history. The nearby universe shows us galaxies as they exist relatively recently. The distant universe shows us younger galaxies. The oldest light shows us the afterglow of an early hot phase. Put together, these clues allow scientists to reconstruct a long story from the first hot dense state to the galaxies we see today. In a much later era, that full chain of evidence could be harder to rebuild. The local sky may still be rich with stars, but the larger cosmic context may be hidden. The universe would still have a history, but the sky would reveal less of it. This is why the disappearing universe is terrifying. It is not simply that things are far, it is that far things can become forever hidden. And the reason is not darkness alone. It is expansion, light speed, and the horizon they create together. Once we understand this, the next part of the story becomes clearer. We have a universe where space expands. We have a horizon that limits what can ever reach us. Now we can look at the galaxies themselves, the distant islands of stars that are slowly slipping away from future view. They are the visible signs of the process. Each distant galaxy is like a marker showing us how expansion has shaped the universe. Its light tells us how far back we are looking. Its redshift tells us how much space stretched during the journey. Its fading future tells us that even the grandest structures can become unreachable, not because they are destroyed, but because the horizon moves between us and them. Because the universe is not disappearing all at once. It is disappearing galaxy by galaxy, horizon by horizon, as the light from the farthest places becomes stretched, dimmed, and lost to the future. The farthest places become stretched, dimmed, and lost to the future. This is how galaxies slip away. That is the quiet meaning of cosmic distance. When we look at a distant galaxy, we are seeing light that has traveled across expanding space for millions or billions of years. During that journey, space did not stay still. It stretched, and as space stretched, the light stretched with it. This stretching is called redshift. But redshift is also part of the disappearing act. As the universe expands, distant galaxies do not simply move farther away in our measurements. Their light becomes longer in wavelength. It loses energy. It becomes fainter. A galaxy that once sent bright visible light may eventually send light that reaches future observers only as extremely stretched radiation. The galaxy is not erased. Its message is. That difference matters. The universe is not becoming empty in the sense that all matter suddenly vanishes. It is becoming empty to observation. The distant signals that once helped reveal the richness of the cosmos become thinner, older, and harder to recover. Future observers may live in a universe still filled with distant galaxies beyond their horizon, but those galaxies will no longer be part of their visible reality. This is the difference between physical existence and observable existence. A place can be real and still be inaccessible. A galaxy can continue through its own history while disappearing from ours. That gap between what exists and what can be known is what makes the idea feel so strange. The universe does not need to destroy something in order to remove it from the sky. They disappear from the observable universe, from the part of reality that can still exchange light with a future observer. They become unreachable, not because they stop being real, but because the expansion of space changes what can ever arrive. The sky is filled with old messages from places whose new messages may never arrive. A deep image of the universe is therefore more like an archive than a live broadcast. It shows ancient light from many distances and many times, all arriving together on one detector. The galaxies appear beside each other in the image, but they belong to different ages of the universe. Some are relatively nearby and recent. Others are so distant that their light left when the universe was young. This makes the slipping away hard to feel. We do not watch a galaxy move across the sky and vanish behind a visible line. We receive less and less useful light from the most distant regions as cosmic time moves forward. The loss is hidden inside wavelength, brightness, and horizons. The expansion of space can create regions that no signal from us can reach, and from which no future signal can return. Once that happens, the galaxy is not merely far. It is outside the future we can share. That is what it means to slip beyond the cosmic horizon. And this is happening because the universe is not just expanding. On the largest scales, the expansion is accelerating. We will come back to the cause of that acceleration, the mystery called dark energy. But the result is already clear enough to feel unsettling. Distant galaxies are not only moving away. Over time, many are being carried into a future where they can no longer send new light to us. At first, this disappearance would not look dramatic. A distant galaxy does not suddenly blink out. It becomes more redshifted, dimmer, and harder to separate from background noise. The galaxy fades not like a lamp being turned off, but like a voice being stretched across a distance that never stops growing. That slow fading is what makes the process so easy to miss. Human eyes are built for immediate change, for motion, flashes, shadows, and sudden loss. Cosmic disappearance is not like that. It is written in data collected across enormous timescales, in the stretching of wavelengths, in the weakening of signals, and in the mathematics of horizons. This is why our own local neighborhood matters. The Milky Way is not alone. It belongs to the local group, a small family of galaxies held together by gravity. Andromeda is part of that family. The Triangulum galaxy is part of it. Many smaller dwarf galaxies are part of it. These galaxies are close enough, in cosmic terms, that their mutual gravity can overcome the expansion of space between them. Andromeda is actually moving toward the Milky Way. In the far future, the two galaxies are expected to merge into a larger galaxy. The stars inside them will mostly not collide directly, because galaxies are mostly empty space, but the galaxies themselves will combine gravitationally over time. The local group will remain as a bound island. This is why the future universe will not be empty everywhere. In the same way, local gravity creates islands that resist expansion. Inside those islands, stars and remnants can remain together for immense lengths of time. Outside them, the expansion between islands grows until the islands can no longer exchange light. The universe becomes separated into regions that still contain matter, but no longer share a visible sky. That future sky would be deeply misleading. An astronomer living in that distant era might look outward and see no obvious sign of billions of galaxies beyond the local structure. Their instruments might reveal stars, stellar remnants, gas, and perhaps the history of their own merged galaxy. But the larger universe could appear empty, because the galaxies that once filled the sky had slipped beyond the horizon. They might conclude that their galaxy is the universe, or at least that the observable universe is far smaller and lonelier than it truly is. We live during a time when the universe has not yet hidden its own biography. That biography is written across distance. Nearby galaxies show one chapter, distant galaxies show earlier chapters. The cosmic background shows an even older one. Together, they allow us to reconstruct a story far larger than the Milky Way. If the distant chapters fade, the story becomes harder to prove from inside one local island. It may understand local physics brilliantly. It may master stars, black holes, planets, and gravitational systems. But the grand evidence of a universe filled with distant galaxies could be missing. Its picture of reality might be smaller, not because its scientists are less intelligent, but because the universe became less generous with information. This is the terrifying part. The loss is not caused by ignorance. It is caused by time. The longer the universe expands under acceleration, the more the distant galaxies fade from future reach. The same expansion that once allowed the universe to cool, form galaxies, and create the conditions for observers also creates a future where those observers see less of the whole. But the trend is clear. On the largest scales, galaxies beyond our bound neighborhood are receding. Their light is stretched. Their signals weaken. Their future connection disappears. The observable universe becomes increasingly dominated by the local gravitational island. This is the cosmic version of isolation. Not one person alone in a room, but a galaxy group alone in the dark, surrounded by a reality it can no longer see. The loneliness here is not emotional in the human sense. It is informational. It means the universe can still be vast while appearing small. It means the sky can still contain stars while hiding the larger structure behind them. It means an observer can live in a real universe of enormous scale and still be denied the evidence of that scale. When telescopes stare into dark patches of sky and find thousands of galaxies, they are catching the universe before the long fade removes much of that view from future observers. Each faint point is evidence that the universe is larger, older, and more structured than any local sky could prove alone. That is why galaxies slipping away is one of the most haunting ideas in space. It is quiet, it is slow, it is almost invisible to daily life, but it changes the fate of knowledge. The universe is full of islands of stars, but expansion decides which islands remain visible to which observers. We happen to live at a time when many islands can still be seen. The future may not be so open. The distant galaxies will continue to recede, their light stretched thinner and thinner until the sky beyond the local group becomes almost silent. The galaxies beyond the horizon do not need to vanish for the universe to feel empty. They only need to stop being able to tell us they are there. A universe can be rich beyond observation and still appear poor from within one isolated region. That is the sadness of cosmic horizons. They do not destroy reality. They remove access to it. And once access is removed, even waiting becomes powerless. In ordinary astronomy, waiting can help. A faint object may become clearer with longer exposure. A rare event may happen again. A telescope may gather more photons. But a horizon is different. If the future light will never arrive, then time does not bring the object closer to knowledge. Time carries it farther away. And the more we understand that, the more the title becomes clear. The universe is disappearing for a reason. The reason is not a monster, not a wall, not a cosmic deletion. It is the stretching of space, the limit of light, and the acceleration that carries galaxies toward permanent separation. But that acceleration leads to an even deeper question. Why is the expansion speeding up? Why is the universe not slowing down under gravity? Why are the distant galaxies being pushed toward a future where they fade beyond our horizon? Those questions matter because gravity seems, at first, like it should pull the universe back together, or at least slow the expansion. Matter attracts matter. Galaxies pull on other galaxies, clusters form, cosmic structure grows because gravity gathers material over time. So the discovery that the expansion is accelerating was not just another detail. It changed the entire future of the cosmos. To answer that, we have to enter one of the biggest mysteries in modern science, the mystery of dark energy. That is the name we give to the unknown cause behind the accelerating expansion of the universe. It sounds like an answer, but it is really a placeholder. It tells us that something is happening on the largest scales, while also admitting that we do not fully understand what that something is. For a long time, scientists expected the expansion of the universe to slow down. Then, the observations told a different story. Astronomers studied distant Type Ia supernovae, bright stellar explosions that can be used as distance markers across the universe. By comparing their distances with their redshifts, scientists could reconstruct how the expansion of the universe had changed through cosmic history. The result was shocking. The expansion was not slowing down, it was speeding up. Distant galaxies were not only receding because space was expanding, the expansion itself appeared to be accelerating, meaning that the universe was moving toward a future where distant regions would be carried away faster and faster. This was not a small correction to the story of the cosmos. It changed the ending. This is where dark energy enters. Dark energy is the name for whatever is driving that acceleration, or at least whatever explains it in our current models. It is called dark because we do not see it directly. We infer it from its effect on the expansion of space. That makes it difficult to imagine. A planet can be pictured. A star can be imagined. A galaxy can be seen in a telescope. Dark energy does not look like any of those things. It does not sit in one place, like an object. It does not glow. It does not have a surface. It is connected to the behavior of space itself, to the way the universe changes on scales far larger than galaxies. And that is what makes it unsettling. It is not a monster at the edge of the universe. It is not a hidden planet. It is not a wall around space. It is something woven into the fate of everything far away. If dark energy continues behaving the way it appears to behave now, then the universe will keep accelerating. Distant galaxies will move farther away. Their light will stretch, weaken, and fade. More and more of the cosmic web will pass beyond future contact. The universe will not become empty because every galaxy is destroyed. It will become empty in appearance because the space between distant regions grows too much for light to keep the connection alive. This is the link between dark energy and the disappearing universe. Expansion makes galaxies recede. Dark energy makes the expansion accelerate. The cosmic horizon turns that acceleration into permanent loss of access. With acceleration, the largest scales of the universe become increasingly separated. Galaxy groups that are not gravitationally bound to each other drift toward isolation. Their old light may still reach us for a while, but their future light becomes unreachable. So the universe does not simply get bigger, it becomes less connected. That is why dark energy is not only a scientific mystery, it is an emotional one. It tells us that the universe has a direction, not a purpose, but a large-scale trend. The future is not a richer and richer connected sky. It is a future where the distant universe slowly slips away. The galaxies beyond our local gravitational island are not waiting forever to be explored, contacted, or observed in detail. Over cosmic time, many are moving toward permanent distance. Not because they choose to move, not because they are being pushed by engines, but because the space between us and them is growing, and dark energy appears to make that growth accelerate. This also means the future of the universe is shaped by something we barely understand. The largest influence on the future of the universe is one of the things we understand least. Scientists can describe its effects. They can place it into equations. They can test models against observations. But the deep nature of dark energy remains one of the biggest open questions in modern physics. And yet, even without understanding its deepest nature, we can see what it does. It changes the future sky. It makes cosmic horizons more severe. It helps carry distant galaxies beyond the range of future observation. This is why the accelerating universe feels terrifying in a quiet way. A dramatic disaster is easy to imagine. A star explodes. A black hole tears apart matter. A planet is destroyed. Dark energy is not like that. It does not leave a bright scar in the night sky tonight. It does not create a single event we can point to and say, "There, that was the moment the universe disappeared." Instead, it changes the background destiny. It works over billions and trillions of years, across the spaces between galaxy groups and clusters, where local gravity is not strong enough to hold everything together. It is not tearing Earth away from the Sun or pulling stars out of the Milky Way in the ordinary future. Bound systems can remain bound, But outside those bound systems, separation grows. That is the key difference. Gravity builds islands. Dark energy expands the ocean between them. Inside the islands, matter can remain connected. Stars orbit galaxies. Galaxies in a local group can remain together. The Milky Way and Andromeda can move toward a future merger because their mutual gravity overcomes cosmic expansion on that scale. But beyond the local island, where other galaxy groups are not bound to us, the expansion wins. The ocean grows wider, the other islands fade, and eventually, their light can no longer cross the gap. They may not see distant galaxy clusters. They may not easily detect the ancient afterglow of the Big Bang. They may not have the same clear evidence that their galaxy is only one small part of a huge expanding universe. Dark energy, in that sense, does not only shape matter, it shapes knowledge. By changing what light can reach future observers, dark energy changes what future science can directly know. The universe is not equally readable at every age. There are errors when the evidence is rich, and errors when the evidence becomes hidden. We happen to live during one of the readable eras. That should feel astonishing. Our telescopes can still see distant galaxies. Our instruments can still detect ancient radiation from the early universe. We can still measure expansion. We can still see enough of the cosmic web to understand that the Milky Way is not alone. But dark energy tells us that this access is temporary. The evidence is not guaranteed forever. The readable universe is slowly becoming less readable. This is why the phrase, "the universe is disappearing," is more than a dramatic title. It describes the fate of information. Over time, the universe hides more of its large-scale structure from any observer inside a bound galaxy group. The galaxies do not need to vanish physically. Their information simply stops arriving. And in science, information is everything. That makes our current view precious. We are not only looking at space, we are looking before the great hiding, before the distant galaxies fade too far, before the cosmic background becomes too cold and weak, before the universe becomes an isolated island sky. The more we understand dark energy, the more this becomes clear. It is not just a mysterious component in cosmological equations. It is the reason the future universe becomes lonelier. It is the reason cosmic horizons matter so much. Still, dark energy should be handled carefully. That uncertainty is not a weakness of the story. It is part of the story. The universe is governed on its largest scales by something still mysterious. The future of galaxies is tied to a question still open in physics. Why does empty space have this effect? Why is the expansion accelerating? Is dark energy constant? Could it change? The universe is expanding. The expansion is accelerating. Distant galaxies are moving toward horizons that remove them from our future. Dark energy is the name attached to that acceleration. So when we look at a deep image of the cosmos, we can see two stories at once. One story is abundance, galaxies scattered across space and time. The other story is impermanence. Many of those galaxies belong to a view that future observers may not share. That gives every distant galaxy a strange sadness. It appears in the image, but it is already leaving the future. Its ancient light says, "I was here." The accelerating universe says, "You may not hear from me again." That is the emotional shape of the physics. The light we receive today belongs to a universe that was more connected in the past than it will be in the future. As acceleration continues, the connected part shrinks in a practical sense. The universe becomes less able to share its distant stories. This is why the accelerating universe feels terrifying. Not because we are in danger tomorrow, not because Earth is being pulled apart, not because stars will vanish overnight, but because the largest view reality gives us is temporary, and one of the most powerful forces shaping that future is still unknown. Dark energy is the reason the disappearance has a direction. With it, the distant galaxies are not only far, They are becoming permanently unreachable. The universe is not just growing older, it is becoming harder to know. And that leads to the next part of the journey. If dark energy keeps pushing the expansion faster, then the future sky will not look like ours. The Milky Way and its local companions may remain, but the distant galaxies, the vast cosmic web, and the evidence of a grand universe beyond our neighborhood will slowly fade. So we have to imagine the sky of the far future, a sky where the universe looks almost empty. That is the future dark energy points toward. Not an empty universe in the absolute sense. Not a universe where every galaxy has been destroyed, every star has gone out, and every particle has vanished. The future sky can look empty, even if the larger universe still contains an enormous amount beyond the horizon. The emptiness is observational emptiness, the silence of light that can no longer reach you. Today, when we look into deep space, we can still see the cosmic web. We can still see galaxies scattered across enormous distances. With powerful telescopes, even a tiny dark patch of sky can reveal thousands of galaxies, each one filled with stars, gas, dust, and history. But the far future will not offer the same view. The galaxies outside our local gravitational neighborhood will continue to recede. Their light will become more redshifted. Their images will grow dimmer. Their future signals will fail to reach us. Over time, the wide cosmic background of galaxies will fade away, leaving only the galaxies bound to our local group. The local universe will remain. The distant universe will vanish from view. That simple contrast is the heart of the future sky. What gravity can hold together remains part of the story. What expansion can carry away slowly leaves the story. The result is not total darkness, but a smaller-looking cosmos, a sky that still has stars, but no longer has the same depth. That difference creates the future sky. Inside the island, galaxies can remain connected. Outside the island, galaxies slip away. The universe becomes like a vast ocean where the nearby land remains visible, but all distant shores sink below the horizon. The Milky Way and Andromeda are expected to merge in the far future. Andromeda is not receding like many distant galaxies. It is moving toward us because local gravity dominates. Eventually, the two galaxies will interact, distort, and combine into a larger galaxy. This future merged galaxy is sometimes called Milkomeda. For observers living far in that future, this merged galaxy may feel like the whole visible universe, not because it is truly all that exists, but because the rest has faded. They may look outward and see stars in their own galaxy. They may see clusters, nebulae, remnants, and perhaps nearby dwarf galaxies still bound to the system. Their sky could still be beautiful. It would not be empty in the way a black room is empty. But compared with our view, it would be cosmically poor. The grand background of distant galaxies would be gone. The deep fields would not reveal endless islands of light. The cosmic web would not stretch across their telescopes. When they looked beyond their local structure, they might find darkness. They might not see what we see. They might not know what we know. They might not discover the same cosmic story from the sky alone. This is one of the strangest ideas in the entire story. A future civilization could be more advanced than us and still have a worse view of the universe. Not because they are less curious, but because the universe itself has hidden the evidence. That reverses the way progress usually feels. We expect future observers to have better tools and better knowledge. In many fields, they probably would. But cosmology depends on what the universe is willing to send. If the sky no longer delivers the same signals, then even the most advanced instruments begin with a poorer archive. This means our age has a strange advantage. We are early enough, relative to the far future, that the horizon has not yet erased the largest visible evidence. Distant galaxies still arrive as light. The early universe still leaves a measurable afterglow, The expansion can still be seen in the redshift of galaxies across deep space. The universe is old enough for us to exist, but not so old that the distant universe has faded beyond recognition. The sky still contains enough information to reveal expansion, dark energy, the cosmic microwave background, and the large-scale structure of galaxies. That is not guaranteed forever. The far future may still produce intelligence, but that intelligence may stand beneath a quieter sky. It may inherit a universe where the greatest evidence has already moved out of reach. The same laws of physics may still apply, but the observational clues may no longer be scattered across the heavens in the same way. In the far future, the cosmic microwave background will also become much harder to detect. Today, it is one of the strongest pieces of evidence for the early hot universe. But as the universe keeps expanding, that radiation will be stretched to longer wavelengths and cooled even further. Future observers may not easily find it. Without the cosmic microwave background, without distant galaxies, without a clear view of cosmic expansion, the evidence for the Big Bang becomes harder to reconstruct from direct observation of the sky. Cosmology requires evidence of the universe beyond the local system. It needs the large-scale view, distant galaxies, redshifts, ancient radiation, and patterns across cosmic distance. If those clues are gone, the biggest story becomes hidden behind the nearest one. The future observers might live inside a galaxy so large and old that it feels like everything. They might ask whether anything exists beyond it. They might point instruments into the darkness and find no clear answer. They might conclude, reasonably from their evidence, that their galaxy is surrounded by a nearly empty void. That conclusion would not be foolish. It would follow from the evidence available to them. This is what makes the idea so unsettling. The sky can lead an intelligent observer toward an incomplete truth, not because the observer failed, but because the evidence has faded. The universe can become harder to read without becoming less real. Our present sky, by contrast, is generous. It gives us galaxies in every direction. It gives us redshift. It gives us the cosmic microwave background. It gives us enough pieces to see that the Milky Way is not the whole story. We are not trapped inside a misleading island sky yet. This generosity may not feel obvious because we are used to it. We grow up under a sky where the universe can be studied, where the largest questions still have evidence attached to them. But seen against the far future, our view becomes rare. The darkness between the stars still opens into distance instead of closing into silence. This future does not arrive suddenly. There is no single night when the universe becomes empty. Instead, it is a slow fading across cosmic time. The most distant galaxies become redder and dimmer. Their light stretches into longer wavelengths. The cosmic microwave background cools. The background of galaxies thins. The observable universe becomes more local. The future sky may still have beauty. It may contain stars, remnants, and the glow of a vast merged galaxy. But it will lack the deep background that tells us we are part of a cosmic web. It will lack the view that makes the universe feel crowded with distant light. That difference matters because beauty is not the same as context. A sky filled with local stars can be beautiful and still hide the larger truth. A merged galaxy can be enormous and still fail to reveal that countless other galaxies once filled the observable universe. The future sky may be rich in local detail, but poor in cosmic perspective. The sky will become simpler. And in cosmology, simpler can mean poorer. In the far future, looking deeper may not reveal a richer universe. It may reveal only the limit of what can still speak to that era. That is why our current cosmic view is precious. We are seeing the universe during an age when deep space still answers. Not completely, not perfectly, but enough to know the universe is expanding, that it began hotter and denser, that galaxies fill the observable universe, and that dark energy is changing the future. Future observers may not get the same answers from the sky, They may still have questions, but fewer clues. This idea makes the far future feel lonely in a way that is not just visual. It is intellectual loneliness. The universe becomes harder to understand from within. The local galaxy becomes a room with no windows, or with windows that once showed a vast city, but now open only onto darkness. That is the kind of emptiness dark energy creates. Not the emptiness of nothing existing, but the emptiness of no longer being able to know what exists beyond. And that is why the future sky feels almost tragic. It is not only dark because light is missing. It is dark because evidence is missing. It is a universe where the true scale may be hidden behind a horizon that no patience, no telescope, and no intelligence can cross. This brings us to the next question, because an empty-looking sky is not only a visual future, it is a scientific future. It raises the possibility that the deepest truths about the universe might one day become almost impossible to discover from direct observation alone. If future observers see an almost empty sky, what will they believe? Will they discover cosmic expansion? Will they know there was a Big Bang? Will they understand that their galaxy is only one island in a universe filled with other islands beyond reach? Or will the universe hide its own truth so well that even brilliant civilizations may never reconstruct the full story? That is the next, and even stranger, part of the journey. The possibility that future civilizations may never know what we know now. That is one of the strangest consequences of a disappearing universe. A civilization can be intelligent, patient, and advanced, and still be limited by the sky it is born under. It can build telescopes larger than anything we have imagined and study stars with incredible precision. But if the distant universe has faded beyond the horizon, then some of the most important evidence in cosmology may no longer be available. Today, we live in a universe that still gives us clues. We can see distant galaxies, measure their redshifts, observe the cosmic microwave background, and map the large-scale structure of galaxies. We can see that the universe is not just one island of stars, but a vast cosmic web stretching across billions of light years. But imagine being born far later. Imagine a civilization living in the merged remains of the Milky Way and Andromeda, long after the other distant galaxies have disappeared from practical view. Their sky might still contain stars. It might still contain stellar remnants, planets, nebulae, and black holes. It might still be beautiful, but when they look beyond their local galaxy, they may not see the rich universe we see. They may see darkness, not because nothing else exists, but because nothing else can still send light to them. This would change the starting point of their science. They might study their own galaxy and conclude that it is surrounded by an enormous, empty region. They might not know, from direct observation, that countless other galaxies once filled the visible universe. They might not have the same evidence that led us to the Big Bang model. Their universe would be the same universe, but it would not be equally readable. If the light no longer arrives, then the best telescope cannot collect it. If the ancient background radiation is stretched too far and cooled too much, then it may become nearly impossible to distinguish. If distant galaxies have crossed beyond future horizons, no observation from the local island can bring them back into view. The evidence moves away. That means future scientists could be more advanced than us and still know less about the large-scale universe from direct observation. This is one of the most haunting ideas in astronomy. The universe does not reveal the same amount of truth at every age. There are windows of knowledge, and we live inside one of them. That window is made by timing. If observers arise too early, there may not yet be heavy elements, rocky planets, stable environments, or long-lived stars suitable for complex life. If observers arise too late, the distant evidence may have faded away. Somewhere between those extremes, the universe becomes both habitable and readable. We are inside that overlap. That does not make humanity central. It simply means our moment has a certain observational power. The universe is old enough to contain us, and young enough that the ancient light still reaches us. This combination is easy to take for granted, but it may not last forever. Our era is late enough for galaxies, planets, chemistry, and life to exist, but it is early enough that distant galaxies still fill our telescopes. The universe is old, but not so old that its largest visible structures have completely faded behind the horizon. We have arrived at a time when the sky still contains the evidence of its own beginning. In the far future, better instruments may not reveal more distant galaxies. They may only confirm that the horizon has closed. A future observer might ask, where did everything come from? That question would be just as natural for them as it is for us. Any intelligent being looking at stars may wonder whether the sky has a history, but the answers available to them would depend on the evidence around them. They might still discover parts of the truth through theory, local clues, or surviving records, but the direct cosmic signs would be weaker. They might study stars and realize they have finite lifetimes. They might understand nuclear fusion. They might discover that stars form from gas and die as remnants. They might study black holes and gravity. They might trace the history of their merged galaxy. But without distant galaxies and the cosmic background, the larger history of the universe would be much harder to reconstruct. They could still reason. They could still build theories. They could still ask whether their galaxy was once part of a larger cosmos. But the sky would not answer as clearly. A future civilization might see only the local result, not the long chain that produced it. It would be like finding a final page of a book, with most of the earlier chapters gone. This is why the far future sky could mislead honest observers. Their conclusions could be reasonable within the limits of what they can observe, and still miss the larger truth that we can see today. That thought should make our own view feel fragile. We do not possess cosmic truth because we are special. We possess certain evidence because we are here during a time when it can still reach us. The universe is not only a place, it is a timed message. Light from the past arrives now. Signals from distant galaxies reach us during this era. The cosmic background is still detectable during this era. The large-scale structure is still visible during this era. If observers appear much later, the message they receive may be shorter. It may have missing chapters. It may have missing galaxies. It may have missing proof. It means the night sky is not just beautiful, it is evidence. The darkness between stars is not empty. It is a doorway into deep time. And right now, that doorway is still open. The terrifying part is not that they would be alone. The terrifying part is that they might believe the universe was always that small. They may never know how crowded the observable universe once looked. They may never know that distant galaxies filled the background of space. They may never know that light from billions of years ago once reached observers and revealed the expansion of everything. They may never know that the sky once proved their galaxy was only one island among countless others. Unless records from earlier eras survive, the truth may become almost inaccessible. This gives present-day astronomy a strange role. It is not only discovery, but preservation. When we measure the universe now, we create records of an era when the sky still reveals its scale. Future observers may depend on such records if the sky itself no longer provides the same evidence. In that sense, every map of distant galaxies is also a message to the future. This is a reversal of the usual story of knowledge. We imagine science as a ladder, always climbing higher. But cosmology shows that the ladder itself depends on the universe providing rungs. Future minds may be brilliant, but the evidence available to them may be poorer. This is not because the universe becomes false. It is because the universe becomes quiet, and silence can be as powerful as darkness. A dark sky can still contain hidden stars, but a silent horizon gives no message. If light cannot cross it, then there is nothing to amplify, nothing to collect, nothing to decode. The observer is left with local evidence and distant absence. This is why the future sky may feel almost like a cosmic illusion. It shows what is available, not what exists. It gives a real image, but not a complete one. It can make a vast universe appear small. That idea also changes how we think about our own observations. When we see distant galaxies, we are seeing more than scenery. We are seeing a privilege of timing. The universe has allowed their light to arrive in our age. The photons that began their journey billions of years ago reach our instruments now, before acceleration carries future messages too far beyond us. Every distant photon is a survivor. It crossed expanding space, carried a piece of a galaxy's past, and arrived before the horizon closed. That is why deep space images can feel so heavy. They show galaxies, but they also show timing. They show light that made it here while it still could. The picture is beautiful, but behind the beauty is a countdown, so slow that no human life can watch it directly. This is the emotional core of the disappearing universe. The loss is not only visual, it is historical and scientific. It is the loss of access to the evidence that tells reality's largest story. Future civilizations may still understand many things. They may study their stars in extraordinary detail. They may learn how their galaxy formed from a merger. They may discover laws of physics that we do not yet know. They may even infer, from subtle traces, that something larger once existed. But the straightforward evidence we have today may be gone. That is a strange and beautiful position. It means our view is not ordinary. It is temporary. It is a cosmic window. And the more we understand future observers, the more that window matters. We can see why the present universe is not just a random stage. It is an era when evidence from many distances and many times overlaps in the sky. We can see stars in our galaxy, galaxies beyond our galaxy, ancient radiation from the early universe, and the large-scale pattern of cosmic expansion. The sky is layered. The layers tell the story. One day, many of those layers may be gone. That is why future civilizations may never know the truth in the same way. They may still search, but the universe may no longer give them the same clues. Their reality may be vast, but their window may be small. And that brings us back to our own place in time. If the future sky becomes almost empty, and if future observers may lose access to the evidence we have, then our current age becomes more important than it first seemed. We live in a rare cosmic window, a time when the universe is still old enough to contain observers, but young enough to show us where everything came from. That is the rare cosmic window we live inside. It is easy to forget how unusual this moment is, because to us, the universe has always looked this way. The stars have always seemed old. The night has always seemed deep. The galaxies in telescope images feel like a permanent background to reality. But the universe does not offer the same view forever. And far in the future, the opposite problem appears. The universe may still contain observers, but the distant evidence may be gone. Galaxies beyond the local island may have faded beyond the horizon. The cosmic microwave background may be stretched and cooled until it is nearly impossible to detect. So our time sits between two limits. Too early, and there are no observers like us. Too late, and the universe hides too much. We exist during a middle era, when the universe is readable. That word matters. Readable. The cosmos is not only visible to us, it is interpretable. The light arriving from distant galaxies gives distances, ages, motions, and the history of expansion. The ancient background radiation carries a record of the early universe. The large-scale pattern of galaxies reveals how gravity shaped matter across billions of years. The sky is a document, and we live while many of its pages are still arriving. Some of those pages are close and recent. Some are distant and ancient. They do not arrive in order like pages in a normal book. They arrive together as a sky. A nearby star, a distant galaxy, an ancient radiation can all be measured in the same era, even though they come from different chapters of cosmic time. That is what makes our window so valuable. It does not only show one part of the story, it lets many parts overlap. We can see nearby stars and distant galaxies at the same time. We can study the sun and also light that began traveling before Earth existed. We can measure galaxies whose images come from billions of years in the past. We can detect the afterglow of the early universe. That is an extraordinary privilege of timing. Not a privilege in the sense that the universe chose us. The universe does not choose. But the laws of physics placed observers like us in a universe that is neither too young nor too old for cosmic evidence. Stars had time to create heavier elements. Planets had time to form. Life had time to emerge. And the distant universe had not yet faded beyond recognition. This overlap may be one of the most important facts about our existence. We are late enough to ask. We are early enough to see. The more you think about that, the more the title changes. The universe is disappearing for a reason, but it has not disappeared yet. We are watching before the long silence becomes complete. We are looking across a sky that still contains the traces future observers may lose. We are living in the age when the universe can still tell on itself. It can still reveal that it began hotter and denser. It can still reveal that space is expanding. It can still reveal that expansion is accelerating. It can still reveal that our galaxy is not alone. And because those clues still exist, we can understand that the sky is temporary. That is the strange circle of the story. The evidence we see today is what tells us that future evidence will fade. The distant galaxies visible in our telescopes are what teach us that distant galaxies will one day become unreachable. The cosmic microwave background is what teaches us about the early universe, while also showing how expansion stretches ancient light into weaker and colder forms. The universe gives us enough information to understand that information can be lost. This makes the present age feel fragile, but also meaningful. There is a strange humility in that. We are not standing at the center of the universe. We are not seeing everything. We are not beyond the limits of horizons. But we are seeing enough to know there are limits. We are seeing enough to know that the future view will change. We are seeing enough to know that our sky is a temporary form of access. A deep image of the cosmos is not just a view of what exists. It is a view taken during a certain window of cosmic time. It shows galaxies before they fade from future reach. It captures ancient light before the horizon closes further. That is why astronomy is not only exploration, it is preservation. Every time we map the distant universe, we are saving a piece of the sky as it can be seen now. Every redshift survey, deep field, and measurement of ancient radiation becomes part of a record made during the readable era. The universe is not disappearing tomorrow. The night sky will not suddenly lose its galaxies in a human lifetime. The cosmic window is vast compared with us, but it is not infinite. Our view of the universe belongs to a particular age, just as surely as stars belong to particular lifetimes. That richness is not only in the number of galaxies, it is in the range of time the sky gives us. Nearby objects show recent cosmic history. Distant galaxies show earlier eras. The cosmic microwave background shows a time before stars. Together, these layers let us see the universe not as a single present moment, but as a story unfolding from past to future. Their sky may be deep locally, but shallow cosmologically. It may show them what is near, but not what the whole universe once looked like. It may contain beauty without context. Our sky still has context. That is the gift. Context is what turns light into understanding. A single star tells one story. A galaxy tells a larger one. But many galaxies at many distances tell a history. They show change across time, not just objects across space. That is why the present sky is more than a collection of lights. It is a layered explanation. When we look at a galaxy billions of light years away, we are not just seeing a smudge of light. We are seeing the universe at another age. When we compare many galaxies at many distances, we are building a timeline. When we measure redshift, we are reading the stretch of space itself. This is what it means to live in a cosmic window. The universe is open enough to study itself. This does not mean our view is complete. There are horizons beyond which we cannot see. There are questions we cannot yet answer. We do not know the full nature of dark energy. We do not know the total size of the universe. We are not at the end of understanding, but we have enough evidence to know the outline. We can see that the universe had a beginning in a hot, dense state. We can see that it expanded and cooled. We can see that galaxies formed. We can see that the expansion is accelerating. We can see that the far future becomes more isolated. That outline may not always be so accessible. This is why the disappearing universe is not only terrifying, it is also beautiful. The terror comes from the loss. The beauty comes from the timing. We are here before the loss is complete. We can still look outward and see that the darkness is full of galaxies. We can still look backward and find ancient radiation. We can still see enough of the cosmic web to understand that our local world is not the whole of reality. The future may not have this view, but we do. And that changes the meaning of looking up. Looking up becomes more than wonder. It becomes witnessing. The distant universe is still visible enough to tell us that reality is larger than the local world, larger than the Milky Way, larger than the future island that may one day remain. We are seeing the cosmos before its widest evidence disappears from view. The night sky is not simply above us. It is a temporary opening into the larger story. Each galaxy in the distance is a reminder that the universe is still speaking. Each photon that arrives is a message that made it before the silence. This is the calm urgency of cosmology. Not urgency because disaster is near, urgency because the view is finite, because the evidence is temporary, because the largest story ever discovered is available during an era that will not last forever. Those connections are invisible in daily life, but they are real. A photon from a distant galaxy can cross billions of years and end inside a detector near Earth. A faint microwave signal from the early universe can still be measured. The positions of galaxies across the sky can still reveal the shape of cosmic history. That connection will weaken in the far future. But now, it remains. This is why our age is not just scientifically useful, it is emotionally powerful. We are not looking at an empty sky after the story has faded. We are looking while the story is still visible. We are not in the first darkness before stars, and not in the final darkness after the galaxies disappear from view. We are between them, in the luminous middle, when enough has happened for life to ask what happened. That may be the rarest thing of all. Not simply that life exists, but that life exists while the universe can still explain itself. And this leads us naturally toward the larger future, because the cosmic window does not remain open forever, and the disappearance of galaxies is only one part of the universe's long decline. Even inside the local island, stars do not burn forever. Gas is not infinite. Star formation changes. Galaxies age. The sky not only loses distant galaxies, over longer times it also loses new light. The universe does not only hide its distant past, it slowly grows older. So, after understanding that we live in a rare window, we have to follow the story farther, past the loss of distant galaxies, past the isolation of the local group, into the long fade of the universe itself, where stars become rarer, galaxies become older, and the cosmos moves toward a colder and darker future. Because the disappearance of distant galaxies is only one part of the story. Dark energy carries the faraway universe beyond our future view. But even inside the local island, time continues. Stars keep burning their fuel. Galaxies keep aging. Gas is used up or locked away. New stars become less common. The universe slowly becomes older, colder, and less full of new light. This is the long fade. It is the part of cosmic history that comes after the universe has already shown its brightest face. The galaxies may still exist, the stars may still shine, but the trend has changed. Instead of a universe becoming richer with new light, we begin to imagine a universe spending the light it already has. It is not a sudden ending. It is not a single explosion. It is not a moment when the entire sky turns black at once. The universe changes gradually, quietly, and almost beyond imagination. On human timescales, stars feel eternal. On cosmic timescales, even stars are temporary flames. Every star is burning borrowed time. A star shines because it has fuel. Deep inside, nuclear fusion releases energy that escapes as light and heat. But fuel does not last forever. Massive stars burn quickly and die violently. Smaller stars live much longer, sometimes for extraordinary lengths of time. But even the longest-lived stars are not infinite. The age of starlight has a beginning, and it has a future decline. Today, the universe is still bright enough for galaxies to glow. New stars are still forming in clouds of gas. Other galaxies still shine across deep space. The universe is old, but it is not dark yet. We live during a time when stars are still common and the cosmic story is still illuminated. But star formation will not continue forever. Stars are born from gas, especially cold clouds of hydrogen and other material inside galaxies. Over time, that gas is used to build stars, heated, blown away, locked into remnants, or trapped in forms that do not easily create new stars. Slowly, the supply of easy star-making material declines. The universe begins to run out of fresh fire. That phrase sounds dramatic, but the process is ordinary physics. On enormous scales, star formation depends on available gas, on gravity, on the conditions inside galaxies, and on time. As more material becomes locked inside stars and remnants, the easy fuel for new generations becomes harder to find. The universe can keep glowing for a very long time, but the peak of renewal does not last forever. Galaxies become redder, new stars become rarer. The average light grows older. This is a different kind of disappearance from the horizon. The horizon removes the distant universe from view. Stellar aging changes the light within the parts that remain. Even if future observers are inside a bound galaxy, even if they still have a local sky, that sky will not stay young forever. The stars around them will age. The brightest, short-lived stars will vanish first. The long-lived red dwarfs will remain far longer, glowing faintly for immense stretches of time. So the future universe may not be completely dark for a very long time, but it will be dimmer, quieter, less dramatic, and more dominated by old stars and remnants. The sky of the far future may still contain points of light, but fewer of the bright young stars that shape the galaxies we know today. The great star-forming regions may become rare. The glowing nebulae may fade. The cycle of birth and death that makes galaxies look alive will slow down. Everything that makes the universe visually rich depends on time, fuel, and connection. Dark energy weakens connection across cosmic distances. Stellar evolution consumes fuel. Expansion stretches ancient radiation. Together, they move the universe toward a future that is emptier in many different ways. Emptier in visible galaxies. Emptier in new stars. Emptier in useful signals. Emptier in warmth. This is the slow transformation from a bright universe to a colder one. The universe had a dark beginning before the first stars. Then, the first stars ignited and began the age of light. Galaxies grew. Heavy elements formed. Planets became possible. Life became possible. observers became possible. And now, after all of that, the universe is moving toward another kind of darkness. Not the original darkness before stars, but the final darkness after most stars have burned down. That makes the age of light feel like a bridge. It connects the early featureless darkness to the far future darkness. It is during this bridge that galaxies become visible, planets become possible, and the universe can be studied by anything living inside it. The bridge is long, but it is still a bridge. The first darkness was waiting for light. The last darkness remembers it. That is the deeper shape of cosmic history. A universe that begins hot and dense, expands, cools, forms stars, shines for a long age, and then slowly fades. The disappearance of distant galaxies is part of this larger aging. In our era, we can still see birth and death together. Stars form in nurseries while other stars explode or collapse. Galaxies collide and trigger new activity. The sky contains youth, maturity, and decay at once. In the deep future, youth becomes rarer. The universe becomes less like a growing forest and more like an ancient landscape where most of the firewood has already burned. This is why the long fade is so important to the whole video. The title says the universe is disappearing, and at first that sounds like galaxies moving beyond the horizon. But the disappearance is also the gradual decline of the universe's ability to produce new light. The sky is not only losing distant information, it is slowly losing the conditions that make it glow. Star formation is the universe renewing its visible life. When that renewal slows, the future changes. A galaxy with active star formation contains short-lived blue stars, glowing gas, and young clusters. A galaxy that no longer forms many stars becomes older and redder. It may still contain enormous mass, but its light tells a quieter story. The universe becomes less blue, less active, less young. This is not just a change in appearance. It is a change in what the universe is doing. A young, active galaxy is still turning gas into new stars. An old, quiet galaxy is mostly carrying the light of what was formed long before. The future moves more systems toward that older state. This color change is not just visual, it reflects physics. Blue stars are usually massive and short-lived, while redder populations often point to older stars. As star formation declines, the light of the universe shifts toward older stellar populations. The cosmos does not need to go dark instantly. It can age into dimness. That is far more realistic, and in some ways far more haunting. This connects to the cosmic horizon in a subtle way. If distant galaxies fade beyond view, future observers lose the large-scale universe. If local stars also age and new stars become rare, they lose the bright activity within their own island. It is a double narrowing, less to see beyond and less new light within. That is the long fade of the universe, a closing horizon, an aging galaxy, a cooling background, a slower sky. That perspective makes the present feel different. The fact that stars still form matters. The fact that distant galaxies still shine into our telescopes matters. The fact that the cosmic background can still be measured matters. We are not only alive in space, we are alive during the bright, readable era of space. The long fade makes that readable era feel more precious, because readability depends on brightness, contrast, and evidence. A universe with active galaxies, ancient radiation, and distant light gives observers many ways to reconstruct the past. A universe of dim remnants and isolated islands gives fewer clues. The long fade does not only change the sky, it changes how much the sky can explain. Because one day, the universe will not look like this. The deep sky will not be filled with the same distant galaxies. The local galaxy will not be young in the same way. The background radiation will not carry the same accessible message. The stars will not keep forming at the same rate. The universe will be older, colder, dimmer, and more silent. This is the broad future hidden inside the present. Every star shining tonight is part of a temporary age. Every galaxy in a deep image belongs to a view that will not last forever. The long fade reminds us that the universe is not only expanding through space, it is aging through time. And aging changes everything. That is why the final meaning of the disappearing universe is not only fear, it is loss. The loss of distant galaxies from view, the loss of new starlight over time, the loss of cosmic evidence, the loss of a sky that can reveal its own origin. But loss also gives the present weight. If the universe were always equally visible and readable, our moment would feel less fragile. But because the view is temporary, looking becomes meaningful. The fact that we can see the cosmic web now matters precisely because one day it may be gone from the sky. The fact that stars still form matters because one day star formation will fade. This is where the calm and the terror meet. The universe does not need to end in one dramatic moment to be temporary. It can fade across timescales so vast that the fading becomes part of its nature. It can become emptier not by being erased, but by becoming unreachable, dimmer and older. That is the long fade. And now the final question becomes clearer. When we say the universe is disappearing, we do not mean it is being destroyed in front of us. We mean that the universe is slowly hiding its own scale, aging past its brightest era, and carrying much of its evidence beyond the reach of future observers. So the final chapter has to bring everything together: expansion, horizons, dark energy, the future sky, the rare cosmic window, the long fade. Because the universe is not disappearing for no reason. It is disappearing because space expands. Light has limits, stars have lifetimes, and time only moves forward. The disappearance is not a single event. That is important because the human mind likes clear endings. We understand a light turning off. We understand a door closing. We understand something being there one moment and gone the next. But the universe works on scales where endings can be stretched into processes so long that they become almost invisible from the inside. It is not one galaxy vanishing in a flash. It is not the universe being erased by something outside it. It is the slow result of the rules the universe already follows. Space expands. That expansion stretches the light from distant galaxies. The farther away those galaxies are, the more the growing space between us changes their signals. Over immense time, many of them move beyond the range from which future light can reach us. That is one kind of disappearance. The disappearance of connection. A galaxy can remain real, but stop being part of our observable future. It can continue its own history somewhere beyond the horizon, while no new message from it ever reaches our local sky. The galaxies do not need to be destroyed. Their light only needs to stop arriving. Then there is dark energy. The name is mysterious because the thing itself is mysterious. We do not yet fully understand what dark energy is, but observations show that the expansion of the universe is accelerating, and that acceleration changes the long-term fate of distant galaxies. It makes the cosmic horizon more severe and turns distance into isolation. Today, our telescopes can still see galaxies across deep space. We can still map enormous structures. But in the far future, observers inside our local gravitational island may not see that same universe. The distant galaxies may have faded from view. The evidence that now reveals the scale of reality may become nearly impossible to recover from the sky alone. That is not just a loss of beauty, it is a loss of knowledge. A future civilization may be intelligent and advanced, But if it is born too late, the universe may not give it the same clues. It may look outward and see an almost empty sky, while never seeing the distant galaxies that once filled the observable universe. Then there is the long fade of stars. Even inside the local island, time continues. Stars burn fuel. Gas is used up. New star formation slows. Galaxies age. The brightest and shortest-lived stars vanish first. The universe becomes redder, quieter, and more dominated by old stars and remnants. So when we say the universe is disappearing, we mean all of this together. Distant galaxies disappear beyond horizons. Cosmic evidence disappears from future skies. New starlight becomes rarer. Ancient radiation cools. The larger story becomes harder to read. The universe does not vanish in one dramatic moment. It becomes less accessible, less connected, less luminous, and less able to explain itself to those who come later. That is why the idea is terrifying. Not because it threatens us tonight. Not because the stars will be gone tomorrow. Not because Earth will suddenly fall into darkness. It is terrifying because it shows that even the universe has a temporary face. The cosmos we see now is not the cosmos that always was, and not the cosmos that always will be. We are seeing it during a particular window of time, when it is old enough to contain planets, chemistry, life, and observers, but still young enough for the distant universe to be visible. We are seeing it while ancient light is still arriving. We are seeing it before the horizon has hidden too much. We can see the cosmic microwave background. We can see distant galaxies. We can measure redshift. We can learn that space expands, that the expansion accelerates, and that the universe had a hotter, denser past. That is the strange gift of our era. The universe is still readable. Not completely. There are still horizons beyond which we cannot see. There are still mysteries we have not solved. We do not know the full nature of dark energy, or the full size of everything that exists, but the evidence we do have is rich enough to tell a vast story. This is why the disappearing universe is not only a dark subject, it is also a beautiful one. The beauty comes from the fact that we can understand it at all. We are temporary beings, living under a temporary sky, using temporary instruments, and yet we can measure processes that stretch across billions of years. We can look into darkness and find history inside it. Every distant galaxy in a deep image is a sentence from the past. Every redshift is a clue that space has grown. Every faint patch of ancient radiation is a memory from when the universe was young. One day, that conversation becomes quieter. But right now, it continues. That phrase matters more than it seems. Right now, the conversation continues. Right now, the distant universe is still part of our evidence. Right now, the cosmic past is still arriving as light, and our instruments are still young enough, curious enough, and sensitive enough to listen. That is why looking up matters. The night sky is not just scenery. It is evidence. It is a temporary opening into the largest story we know. When we look into space, we are not only looking outward, we are looking backward, across time. And the more we understand that, the more the title changes again. The universe is disappearing for a reason. But that reason is not evil. It is not punishment. It is not design. It is simply the nature of a universe with expansion, horizons, stars, fuel, and time. Space expands because that is how the universe evolves. Light has limits because information cannot travel instantly. Stars die because fuel is finite. Evidence fades because signals stretch, weaken, and sometimes never arrive. The terrifying part is not that the universe is broken. The terrifying part is that the universe is working exactly as it should. There is no need for a cosmic monster. There is no need for a final war. There is no need for a sudden deletion. The universe can become almost empty-looking through ordinary physics. The same expansion that shaped the cosmos also isolates it. The same time that allows stars and planets to form also carries them toward age. The same light that teaches us the past also has a horizon beyond which it cannot reach. This is what makes the story calm and frightening at once. Nothing is rushing, nothing is screaming. But everything is changing. The galaxies are receding, the light is stretching, the background is cooling, the stars are aging. The future is narrowing, and still, tonight, the universe is not silent. Not yet. The stars still shine. Galaxies still send ancient light across space. Telescopes still collect messages from the early universe. The cosmic web still leaves traces. The sky still tells us that reality is much larger than our local world. We live before the deepest silence. That is the final emotional answer. The universe is disappearing, but we are here while it can still be seen. We cannot stop the expansion. We cannot keep every galaxy inside our future horizon. We cannot make stars burn forever. We cannot freeze the universe in its current form. But we can understand. We can observe. We can preserve records of the sky as it looks during this readable age. In a universe where the evidence will not last forever, understanding becomes a kind of memory. Astronomy becomes a way of remembering the universe before it hides itself. Every map of galaxies is a memory. Every measurement of ancient light is a memory. Every deep image is a memory. So when the far future becomes dark, when the distant galaxies no longer appear, when the cosmic background has cooled almost beyond recognition, and when the local island is surrounded by silence, the universe will not have become meaningless. It will simply have moved into another era, a quieter era, a colder era, an era where the largest story is harder to read. But tonight, the story is still readable. Tonight, the distant galaxies are still there in our telescopes. Tonight, the ancient light still reaches us. Tonight, the universe still shows enough of itself for us to understand that one day it will not. And maybe that is why this subject feels so powerful. It turns the night sky into something fragile. Not fragile because we can break it. Fragile because it is a moment, a view, a temporary alignment between cosmic history and observers capable of asking what it means. The universe is disappearing for a reason. The reason is expansion. The reason is dark energy. The reason is the speed of light. The reason is the lifetime of stars. The reason is time. And the terrifying truth is that none of these reasons are strange exceptions. They are the basic rules of the universe itself. So the final lesson is not that the universe is empty. It is that the universe is becoming harder to reach, harder to read, harder to know, and one day perhaps, harder to remember. Thank you for watching this journey through the disappearing universe. If you enjoyed this calm exploration of deep space, subscribe to the channel for more space documentaries like this. Leave a like if you want more slow journeys through the mysteries of the cosmos, and write in the comments what distant mystery you want to explore next. Tonight, you are watching the Just About Space channel, talking about the universe is disappearing for a reason, and it's terrifying. Sleep well and keep looking up. Good night.